Hello everyone, this is Dr. Mihir Shah once again with another video. In this video, we are going to have one last minute revision under the subject operation research. This is basically for those who haven't yet covered the entire topic. For them, I have created a sequence of videos which all can cover up within 2 hours. Okay, within 2 hours, the most important topics. Okay, so that all can easily pass. Okay, for those who haven't yet started or have not been done that great in the subject. So this video is basically on request by many students to cover up the syllabus in the most easiest manner. So I have picked out few topics which will cover up majority of the paper, which you can easily attempt and clear your examination. Again, a very important video for all the TYBMS SEM-VI students. Now this is the part 1 of the series. Okay, the entire thing will get done within 1.5 hour to 2 hours. You all will be able to cover up the entire topic. Okay, the entire subject, I mean. Chalo. So let us start with the very first part. Okay, the very first topic we will be covering up is called as the game theory. This is one of the most simplest topic in OR. Okay, so let us see how to solve sum based on game theory.
Okay, now if you look carefully, there are two sums on this particular sheet. So first we're going to solve the very first sum. It is given that you are given the payoff, player A, player B. Player B have 4 alternatives, player A has also 4 alternatives, and all the payoffs are given to us. Find the maximum and minimax strategy and what is the value of game. Okay, whenever such kind of question is given in our solution, you need to make the similar table, or okay, you can make the similar table, the one which I have shown here. So we'll have to write player A, player B, all the alternatives of B, all the alternatives of A, and all the values which have been given from the question. Okay, that's the first step. Now, in order to start the sum, the very first thing what you need to do is, on the right side, we'll have to write row minima. Okay, row minima means the lowest value from each row should be noted down. So from row 1, that is called as A1, the minimum value is -12. From row 2, the minimum value is 0. From row 3, it is -8. From row 4, it is -9. Okay, the very first step is get the row minima. Next, column maxima. From each column, we'll have to select the maximum value. So from B1, the maximum value is 13. From B2, the maximum value is 14. From B3, it is 0, and from B4, it is 5. Okay, next step, since it's a minima, we need to find maximum. Maximum means from your row minima, the maximum value. Which is the maximum value? -12, 0, -8, -9. The highest value is 0. Okay, so I'll have to show that this is the maximum value. From column point of view, since it was maxima, we need to find minimax. That's from the maximum find the minimum value. So from 13, 14, 0 and 5, the minimum value is 0. Okay, so first we did row minima, then we did column maxima, then we found the maximum, and then we found the minimax. Now whatever values you have found, now you have to look at this carefully. We found 0 and 0. This has to always be equal. Okay, the maximum and minimax has to be equal. The point where both of them are equal is known as my saddle point. Okay, that will be called as a saddle point. So but after getting this, we have to conclude number 1, the optimum solution. Okay, now we have to directly write with the final answer with the optimum solution or optimum strategy. Okay, the optimum strategy or solution for A is, now for A, which one was selected? The one which maximum, whatever gets selected, that is the strategy, that is A2. And the payoff you have to write, you have to look at the row minima column. the one which got selected, okay, the value which got selected, that will be considered. Okay, once you all get the the optimum strategy, we got selected in this A2. Afterwards, remember, the one value whichever gets selected now, that will be considered as 1, and all other values from row minima will become 0, because those are the strategies that are not to be taken. So in our case, just understand this: the first value wasn't to be considered, so it will be considered 0. Second was considered, so 1. Third and fourth are again not considered, so 0 0. So this is the strategy 0 1 0 0. Okay, same way we'll have to find the optimal strategy. So solution or strategy, any word you can use there. It will be better if you use the word strategy. For B will be, now in B, okay, the third value was selected, so it is called as B3. And the strategy will be, first one was not selected, second is not selected, the third one is selected. So 0 0 1, and last is also not selected, so it will be 0 0 1 0. And optimum strategy for A was 0 1 0 0. Third, the saddle point okay, the saddle point is equal to 0, therefore value of the game is equal to 0. That's my final answer. Okay, again, a very simple sum. You just have to go through 3 to 4 steps. Okay, chalo. Now similarly, let us start with the next sum. You are given the payoff. Again, we have player A, player B, and various strategies are given. Find the maximum and minimax strategy and what will be the value of game. Step number 1, we need to first find row minima. In the first row, the lowest value is 200. In the second row, the lowest value is -100. In third, the lowest value is -20. In fourth, the lowest value is 50. The next step, column maxima. First value, the highest value is, in first column, the highest value is 500. In the next, it is 400. Third mein it is 200, and fourth mein it is 240. Row minima, column maxima. Next, we need to find maximum. From row minima, the highest value is 200. So I've noted down this as 200. From column maximum, in that line we'll have to find the minimax. From the maximum, the minimum value is 200. Okay, so this 200 and this 200, they both match. This is nothing but our saddle point. Once I get that, number 1, the optimum strategy for player A was the first one, and the strategy will be, the first one is selected, so 1 0 0 0. Similarly, for optimum strategy for B was, the third one was selected, so third is selected, so it will be 0 0 1 0. Third, the saddle point was 200, therefore value of game equals to 200. Okay, again, very simple. You just have to follow those basic steps, and with that you will be able to solve the sum.
Okay, now the second topic is under job sequence with 2 machines. Again, a very simple topic, okay, which can be learned very quickly. Okay, so let us see how to solve sum based on job sequence having 2 machines.
Okay, today we'll be solving sum related to job sequencing problem with n number of jobs and 2 machines. Okay, now in order to solve the sum, okay, we'll first go through the question and see what is the question all about. Okay, so in the question we have 5 jobs, 1 2 3 4 and 5, we have two machines A and B, and these are all the values, okay, about the number of hours taken by machine A and machine B in order to complete the respective job. Now in this sum we need to find two things: one, the idle time, and second, the total elapsed time, the total time taken by both the machine to complete the jobs. Now in order to solve that, we'll start by one, okay. We'll go in this particular procedure and complete the sum. So step number one, we first need to find the optimal job sequence. Now in order to find the optimal job sequence, okay, we need to create a table. Now check, there are 5 jobs available, so we'll create a table which will have 5 columns. Now remember, if there are two machines, the left side, okay, the left side of the table will represent A, or machine A, and the right side will represent machine B. Now we will start finding the optimal job sequence by taking the least, taking the machinery, or taking the job which has the least number of hours. Okay, now if that particular hour appears in machine A, we will note from the left side, and if that least hour appears in machine B, then we'll note it from the right side. Okay, so let us see how to do this by actually solving it. Okay, now in this entire question, we'll try to find out the least hour taken, or the most lowest number. So the lowest number, or the lowest hour which is given, is 1. This is the least amount present. Now the machine corresponding to this one is machine A. Now if it is machine A, we'll have to note from the left side. Now machine A has least 1 hour, and it is representing job number 2. So we'll note down here job number 2. Now since I have already used this particular columns is of no use. Now let us find the second least. Now the second least hour is 2 hours, and that is under machine B. So now that appears on the right side. Okay, it represents job number 1, so we'll note down job number 1. Again, this is done. After 2, the next least is the third, or 3 hours. Okay, it is represented by job A. It is represented by job A, so it will start from the left side. Okay, and it represents job number 4. The next least number is 4, and this is again over, so 4. Okay, it is under job B, okay, machine B, and job number 5. So since it is machine B, we'll note it down on the right side. Okay, and lastly we have number 7, and only 1 spot available, so we can note it directly. So our optimal job sequence is, first, job number 2 will be done, then job number 4, job number 3, job number 5, and lastly job number 1. Now let us see how we need to calculate, or what is the format of calculation of idle time and the elapsed time. So now this is the table that we need to create. The first column will have jobs. Now here, since there are two machines, so we'll have machine A, and second will be machine B, and we'll have the idle time. Now in machine A, we need to find the in time and out time. Similarly for B, in time and out time. And idle time we have to find for machine A and machine B. So this is the basic format for solving job sequencing problem. So first step was we need to find the optimal job sequence, and secondly we need to do the calculation. So this is, I can say, second step where we're going to do the actual calculation. Now under job, we'll have to note down the optimal job sequence that we have got. So here it will be job number 2, 4, 3, 5 and 1. Okay, now let us see how we need to solve this. Okay, now always remember कि the first machine job, the end time will always be 0. मतलब from 0 hours you're going to start your work. Now check in machine A under job 2, how many hours did it take? So for machine A under job 2, it has taken 1 hour. So my out time will be 0 plus 1, which is 1. So it has taken 1 hour. Now for one job, whatever is the out time, for the second it will become the end time. So we cross it, we bring 1 down. So now next job is job number 4. In job number 4, for machine A, it has taken 3 hours. So my out time will be 1 plus 3, which is equal to 4. We bring 4 down. Okay, so my next out time will be 4 under job number 3 is 9 hours going to take. So 9 plus 4 is 13. Again we bring 13 down. Next will be 13 plus, in job number 5 it has taken 10 hours. So here it will become 23. Okay, we bring 23 down. Okay, and lastly it will be 23 plus job number 1 has taken 5 hours. So total is 28. Okay, so we first start with 0 and then we keep adding the number of hours that have been taken by the respective number of job. That was for machine A, the first machine. Now let's see how to start the second machine. Always remember, first machine first out time will be equal to the end time for the second machine. So whatever is the out time under your first machine, that will become your end time for the second machine. And now we have to follow almost similar procedure, but we just have to be careful in one point that we'll see. Okay, machine B under job 2 has taken 6 hours. So the out time will be 1 plus 6, which is equal to 7. Okay, again the rule was whatever is the out time will become the end time, but now here you have to be very careful. If the out time is more than, if the out time of machine B is more than that of machine A, then it has no issues. You can directly bring it down. So here it became 7. Okay, but if it would have been less than the out time of machine A, then there will be one small effect that we'll have to do. So we'll see that ahead, but here as of now it is greater, so we bring it down. So out time for the next job will be, now this is job number 4, which is 8. So 7 plus 8 is 15. Again this is 15. This is 13, 15 is more than 13, so we bring down 15 as it is. Job number 3 it has taken 7 hours, so it will become 15 plus 7, which is equal to 22. Now this is 22. Okay, the next out time of machine A is 23, so you cannot get 22 down. Simple logic, machine A need 23 hours to complete job number 5. Machine B cannot start with 22 hours. It will usually have to start after 23 hours or at 23 hours. So if the number, okay, if the total out time is less than that of the first machine, we bring the same number down. Okay, we carry the out time 23 hours. Okay, we'll bring it here. Now here what happened is, machine B had already finished its work at 22 hours, but it cannot start because machine A will take 23 hours to finish that job. Only after that machine B can start. So here machine B had to actually wait for 1 hour. So the idle time of machine B under this case became 1 hour. Thereafter we can directly solve now further. 23 plus, now job number 5 was 4 hours, so it became 27. Now again 27, I could have bring it down directly, but here it is already given as 28 hours. So you cannot start the job B at 27 hours. So you'll have to start it at 28 hours. Again 1 hour idle time will be recorded. Lastly 28 plus job number 1, it has taken 2 hours. So total became 30. Okay, now let's check here. Now see here, machine A took 28 hours to complete the job, whereas machine B took 30 hours to complete the job. It means machine A had to wait how many hours now here? It had to wait 2 hours. So that was the idle time that machine A had, because otherwise it was all in normal coincidence, like 0 1 1 4 4 13 13 23 23 28. So there's no gap between that. The only gap between us the 28 to 30, so 2 hours idle time. Now machine B started with, after 1 hour. The in time was after 1 hour, so meaning from 0 to 1 it had to wait, so another idle time get appears here. So in total, A had an idle time of 2 hours, whereas B had a idle time of 3 hours. Okay, so to conclude this, number one, we need to first find the idle time. So the idle time for machine A is equal to 2 hours. Idle time for machine B is equal to 3 hours. So the total idle time that the machine was idle is 5 hours. And finally, the total elapsed time, that is the total time taken to complete all the job by both the machine, is the total is 30 hours. Okay, so this is how we have to solve job sequencing problem sum, where there are n number of jobs and 2 machines.
Okay, now the next type of sum that we need to solve is job sequence. Under job sequence itself, we have now with 3 machines. Again, a very simple topic. It is similar to the 2 machine only. The only thing is now, if the moment you have 3 machine, you need to combine it and make it into 2, and thereafter solve it normally. Okay. So chalo, let us see how to solve job sequence sum with having 3 machines.
Now let us see how to solve when there are 3 machines. Okay, now we'll just go to the question. The question states that there are 5 jobs, 1 2 3 4 5. There are 3 machines, A, B and C, and then these are all the data given related to the number of hours each job requires by the respective machines. Now the very first step to solve, okay, to solve job sequencing problem and 3 machines are given, the very first step is we will convert the 3 machines into 2 machines. So we'll write here, let machine G be the addition of machine A and machine B, and machine H be the addition of machine B and machine C. So the first step is we are going to convert 3 machines into 2. So we have to make a table. The first heading will be job. So now there are 5 jobs available. We are converting 3 machineries into 2 jobs. So we have machine G and machine H. In order to find the values of G, the formula is A plus B. That is nothing but the addition of machine A plus machine B. So machine A is 8. So 8 plus 5, we have 13. 10 plus 6 is 16. 6 plus 2, 8. 7 plus 3, 10. And 11 plus 4 is 15. Similarly, to find the values of H, we'll have to add B and C. So 5 plus 4, 9. 15. 10. 3 plus 6, 9. And 4 plus 5, 9. So that was the step number 1. So first step, whenever there are 3 machines, convert those 3 machines into 2 machines. Step number 2, we need to find optimal job sequence. Okay, now in order to find optimal job sequence, we'll have to create a table with 5 columns because there are 5 jobs available. The left side represent machine G, the right side represent machine H. Now we need to pick out one by one, starting from the least number of hours taken. If it represents machine G, will start from the left side. If it represents machine H, we start from the right side. Now the least value available is 8. 8 represent machine G. G means we'll have to start from the left side. And the number of job, what is going to represent is 3. So the very first job that we'll have to do is job number 3. Now next lowest is 9. However, I can see there are 3 places 9. So now there's a tie between the number 9. So the rule is whenever there is a tie, okay, check for the opposite side, opposite machinery number, and check which is the least among them. Now here it is 13, for here it is 9, and here it is 15. The least is 10. So this will be selected. Okay, it represents machine H, so it will be from the right side, and job number will be 4. Okay, once you have cleared it out, we cross it down so we cannot use these two again. Now the next lowest is again 9 itself. So again there are two 9s. So we check the opposite side number. 13 being the lowest, this job will be selected. Again it is from H, so we'll note it on the right side. It represents job number 1, so we'll note down job number 1. The next is again 9 and it represents H, so again we note it down as job number 5. Next is job number 15. It represents, since that was the only place we could have directly written it here. So finally our optimal job sequence is first job number 3, then job number 2, job number 5, job number 1, and job number 4. Now let us see how can we solve in order to get the idle time and the elapsed time. So this is the table that we'll have to create. First column is jobs. Next we have 3 machines. So we have machine A, machine B, and machine C. We'll have to record their in time and out time for machine A, machine B, and machine C. Under job column, we'll note down the job sequence that we have already found from the optimal job sequence. So we have 3, 2, 5, 1, and job number 4. So now let us start solving and see how we can solve this. First, the in time of the first machine will always be 0. Now machine A represents job number 3. Now job number 3 states 6 hours. So your out time becomes 0 plus 6, which is 6. We bring it down. This is job number 2. In job number 2, machine A is taking 10 hours. So your out time will be 6 plus 10, which is 16. 16 comes down. Next, 16 plus job number 5 is 11 hours. So that becomes 27. 27 comes down. Next, job number 1 is 8 hours. So 27 plus 8 is 35. And lastly, 35 plus 7, which is 42. Okay. With this, we have completed the working for machine A. Similarly for machine B, the very first in time will be after the out time of A. So A has taken 6 hours, so the in time will be 6. Now 6 plus job number 3 for machine B is 2. So 6 plus 2 is 8. Now the out time of B is less than the out time of A. So whenever this is less than this, we'll have to note down the higher value, meaning there is some idle time available here. 16 plus in job 2, okay, machine B has taken 6 hours. So which is 22. Now 22 being less than 27, we'll have to note down 27 here. So there will be some idle time available here. So it will be 27 plus 4, which is equal to 31. Again 31 is less than 35, we note down 35 here. So there will be idle time here. 35 plus 5 will give you the total out time. So again 40 is less than 42, so we note down 42 here. So there's idle time available there itself. So 42 plus 3, which is 45. Similarly for machine C will start only after machine B gets done. So machine B's out time will become in time of machine C. So 8 plus third job 8 hours, so which is equal to 16. 16 less than 27, so we note down 16 less than 22, so we note down 22. So there is some idle time here. Next will be 22 plus, this is the second job, so second job has 9 hours, which is 31. 31 equal to 31, so no issues. 31 plus fifth job has 5, so that becomes 36. Now 36 less than 40, we note down here, so there is some idle time here. So next is 40 plus job number 1 is 4, which is 44. Again less than 45 we noted here, so here there is some idle time. Last 45 plus job number 4 is 6, which is 51. Okay, with this we have completed the calculation. Now let us start finding the final answers. The very first thing was the idle time for machine A. Now machine A is all the values are in correspondence, like 0, 6, 6, 16, 16, 27, 27, 35, 35, 42. So there is no gap in between. So there is no idle time in between. However, machine A got done at 42 hours, but the final elapsed time got over at 51. So there's a difference of 9 hours. So the idle time that machine A had to wait was 9 hours. How we got that? 51 minus 42. Similarly, we need to find now the idle time for machine B. Now machine B started the very first job at 6 hours. The very first 6 hours it had waited, that was the idle time. Next, from 8 to 16 it had to wait, so another 8 hours it had waited here. Next, from 22 to 27, so another 5 hours idle time. From 31 to 35, again 4 hours idle. 40 to 42, again 2 hours idle. And lastly 45 to 51, so 6 hours again idle time here. So total 31 hours idle time machine B had. Now idle time for machine C. Machine C started only at 8 hours. The first 8 hours were idle. 6 plus 22, 16 plus 22, so we have 6 hours idle. 36 plus 40, that is 4 hours, and 44 plus 44 to 45, that is 1 hour. So in total 19 hours idle. Therefore the total idle time of the machines A, B and C were 9 hours plus 31 hours plus 19 hours, which is equal to 59 hours. So the total idle time we found is 59 hours. Last thing to find is the total elapsed time, that is the total final hours. It started with 0 and ended to 51. So total elapsed time is 51 hours. So with this we have completed the question solving on job sequencing, where there are n number of jobs and 3 machines. So the first step was convert 3 machines into 2 machines, then find the optimal job sequence, thereafter do the calculation, and then from that calculation find out the idle time and the total elapsed time.